How fast do you think you can run? And how far do you think you can leap? Hi friends, my name is Educator Katie and I'm here at ZooMontana. Today we're bringing you another challenge for the HappyRadFunTimes from Wise Wonders, and it's a fun one. This month you're going to be a scientist, so you need either paper or your journal from one of the previous challenges to write this down, because scientists take data. Today you're going to make a hypothesis about how far you can run and how far you can jump, or one or the other. You can choose one or the other if you want. You'll set up your experiment with all of your tools that you have. You'll do the experiment, collect some data, then you'll do the math and compare it to your hypotheses and to the speed and the leaping distance of two of your favorite animals. For this activity, you will need something to measure with, whether that is a yardstick or a ruler or even a measuring tape. And if you don't have a bunch of them, you can do this outside and just mark the sidewalk or the ground that you're using with rocks or with chalk so that you know how far the distance is. You'll also need a stopwatch and someone who can read that stopwatch for you while you're doing your running. Okay, so my hypothesis was that I can run 20 feet in 5 seconds. And I had two hypotheses. So my other hypothesis was that I can leap 6 feet from just standing, not from a running start. I'm going to do each run and each leap 3 times to get more data. You can do it more times or 1 or 2 or 3 times, however many times you want to do this. And then it's math time. So I'm going to compare my run speed to the top running speed of a wolf, and I'm going to compare my leap distance to the leaping distance of a lynx. All right, friends, here's how it actually went. If you haven't seen the journaling challenge from earlier this year, go check it out right now. You can pause the video right here and go check it out, because what I'm about to show you involves a journal, or at least a piece of paper. Obviously, your journal is not going to be this big, but I needed a big piece of paper to be able to show you what I did. Now, as a scientist, again, we all take data, and one of the most important things for your journal as a scientist is to take the date and write down what you're doing. So I wrote animals in motion, and today's date, which is the 23rd of December, 2020, and it's a Wednesday. Now, again, I wrote my hypotheses. I can run 20 feet in 5 seconds, and I can leap 6 feet, and I just did a tiny little diagram there. And then I have my data section, which is pretty messy, but hang in there with me. All right, now I won't wobble as much. Okay, so for my data, if you noticed, my very first run, I had to not include that one because I went way farther than I thought I could. I went really far. So I had to move my measuring tape down the way so I could accurately record. But once I got all that in place, so 5 seconds per run, right? Run number 1 was 46 feet. Run number 2 was 54 feet. And run number 3 was 50 feet, okay? An average in math is when you add all these things together and then divide by the number of things. So I had 3 runs at 46, 54, and 50 feet. So I added 46 and 54 and 50. And then I divided that by 3 to get my average. My average was 50 feet. And then for my leaps down here, my first leap, again, not a running leap, just from standing, I went 6 feet and 4 inches. My second leap, I went 6 feet 6 inches. And my third leap was again 6 feet and 4 inches. Okay? Now, I put decimals for this one so it would be easier to calculate. I had a decimal column for my running, but it was too fast for me to get the small little inches, so I rounded to the nearest foot that I was by. For the average of my leap, I have 6.33 plus 6.33 plus 6.5 divided by 3, which equals 6.39 feet. And the average is important because I wanted to compare one number to the wolf and the lynx, okay? And again, my question, how fast can I run compared to a wolf, and how far can I leap compared to a lynx? So those are some questions I wanted to answer here. And now it's math time. If you don't know how to do this kind of math yet, that's okay. Just do your best, or have an adult or older sibling help you, or another family member help you. So the wolf's top speed, this part might also require some research on your end. A wolf's top speed is about 35 miles an hour. Okay, my speed on average was 50 feet per 5 seconds, which comes down to 10 feet per second. Sounds really fast, right? But now we have to do some conversions. That means I can go 36,000 feet in 1 hour. Again, sounds pretty good, right? Okay, so now to get from feet to miles, we had to do another conversion. 6.82 miles per hour, which is not as fast as it sounded when we said 10 feet per second, right? Now we're gonna look at the leap distance. However, just to give an extra challenge, and if you're an older kiddo who's done this kind of stuff, try to give yourself an extra challenge too. So I found my Lynx leap distance in meters, so 7.5 meters, but my average leap was 6.39 feet. Now, those are two different measuring systems, so we had to find a conversion for them. So I can leap 1.95 meters. So for my conclusion, for my hypotheses, I can run much faster than I thought. And I can leap about as far as I thought, a little bit over 6 feet. But compared to the wolf, who runs 35 miles an hour at their top speed, I can run 6.82 miles per hour. They're 81% faster. And compared to a lynx, who can leap 7.5 meters, I can only leap 1.95 meters, that means that they can leap 74% farther. All right, my friends, so obviously compared to those two animals, I can't run very fast and I can't leap very far, but it was still really fun. Now it's your turn. Choose one or both activities, make your hypotheses, set up your experiment, run through that experiment, take data, then compare your results with your hypotheses and with a couple of your favorite animals, and let us know how it goes. See you next time.